Today we're going to look at special angle relationships. We learned some special pairs of angles in class yesterday. Specifically, the two most important ones were linear pairs and vertical angles. Just as a reminder, in case you've forgotten, something that looks like this. These two angles are a linear pair. If you have something that looks like this, these two angles are vertical angles. You have to be able to recognize these because it's going to come up all the time. So, for the first set, we did the angle addition postulate earlier, and it's true even for straight angles. So, for example, in this picture, the measure of angle RXS, which would be all of this part over here, plus the measure of SXT, that's all of this part, together that makes this straight angle, right? When we stick those two together, we get a straight angle. And the measure of a straight angle is 180. So we know this whole thing is 180 degrees. So the measure of RXS plus the measure of XXT is going to be 180. And if we want to put that in words, we say that those two angles are supplementary. So, in general, the angles in a linear pair are supplementary. You must know this. This is super important. It's going to come up over and over and over again all year long. The angles in a linear pair are always supplementary. This allows us to find other angles in a picture. So like this. Notice that they're asking us for angle XTW. All right. I know you don't necessarily have highlighters with you, but let me show you. I'm going to outline that angle. Okay, and now I'm going to switch colors. I'm going to highlight this one with yellow. The angle that I know, XTV. All right. Notice how this one, which was blue and then yellow, has turned green? That's where they're stuck together. So are these two adjacent to each other? Yeah. And do you see how this blue and this yellow together make a line? So together, they make a straight angle. These two are a linear pair. And the angles in a linear pair are always going to be supplementary. So that means that if this angle is 140, this angle will be 180 minus 140 is 40. So XTW is 40. All right, next they ask us for WTZ. Well, if we look at this, WTZ is this angle down here. Sorry, it bugs me that this turns off every time. Like when you're writing it, when you quit writing, it doesn't change out. So now you see how this 40 and the angle down here share this side. And their other two sides make a line. So this angle and WTZ are a linear pair. So to find this angle, I'll do 180 minus 40 is 140. That angle is 140 degrees. And then to find YTZ, we can take this original angle, this angle, and I'm just going to do scribbling on this one. Do you see how they're stuck together right here? They share that side, and their other two sides make a line. So they are supplementary. That's going to be 180 minus 140 is 40. This angle is going to be 40 degrees. So anytime you have a linear pair, they're going to be supplementary. Now, hold that thought. I can see you already thinking about it. What do you notice about each pair of vertical angles? Now you can let that thought go. Yeah, they're the same. They are congruent. The vertical angles, the ones across from each other, are exactly the same size every single time. So linear pairs are supplementary. Vertical angles are going to be congruent. So go ahead and turn that over to the back. Vertical angles are always congruent. So we can use those two ideas to find all of the angles in this picture. We'll start with the easiest ones. I think vertical angles are the easiest ones to see and the easiest ones because they're just the same. I don't have to do any math. So if FTA is 47, what angle is a vertical angle to FTA? Yeah, DTC. So this angle is also 47. If you've got an X made by two lines intersecting, the angles directly across from each other will be exactly the same. So if this angle is 65, what other angle do we know? Which one? ATB? No. CTB, right? They have to be directly across from each other. That's going to be 67 degrees. I mean 65. You have a thought?
I have an answer to the problem to find the other half of to find ATB.
Okay, tell me how you would find ATB.
You would subtract 65 from 180.
No.
No? Okay. Good try, man. That was
Okay, so we want a linear pair, right? So we need a line, like this line, and a ray coming off of that line. That's how you make a linear pair. So then what can we do from here, Max?
We do 180 minus 65 minus 47.
Okay, you can do that. What if I only wanted to subtract once?
You add 47 to 65.
Yeah.
And then subtract 180.
These two together, by the angle addition postulate, just adding those two pieces, 65 plus 47 is 112. And that angle is in a linear pair with ATB. So they must be supplementary. So this is 68 degrees.
So does that mean the other one, which one would be
What's its name? The other one.
Oh, ETD?
ETD is
68?
exactly right. Vertical angles are always going to be exactly the same size. Okay, any questions about that? You'll have some like that on your assignment tonight. Let me suggest that since it's in the book, you may want to copy down the diagram or even hold your piece of paper up to the diagram and trace it onto your paper. That way you can write on it. Okay?
Wait, the assignment's gonna be in our cover letter.
Yes.
In the book, yeah. All right, let's solve these for x. So for this one, what type of angles are these two angles? They're vertical angles. And what do we know about vertical angles? Yeah, they're the same. What's the geometry word for that? They're congruent. So that means that 5x plus 9 is going to be equal to 7x minus 5. I'm going to subtract 5x from both sides. I'll have 9 is equal to 2x minus 5. Add 5 to both sides. Dividing both sides by 2, we get that x is equal to 7.
Oh, that was old.
Yeah, it just asks you to solve for x. A lot of times it'll ask you to find the angle. But in this case, it just said solve for that for x. All right, let's look at this next one. These are not vertical angles. What kind of angles are these two angles? You're right, they're adjacent. They're more than that, though. They're a linear pair. Because, and the way to see it is to go, okay, see how they're stuck together here? That's what makes them adjacent, right? So then look at the sides where it's not stuck together. See how that makes a line? That's a linear pair. And linear pairs are, what's their relationship? I'm sorry? I heard something, I just couldn't hear it over the air conditioner units. One word.
Oh,
Yes,
supplementary?
they're supplementary. Good use of your notes. Linear pairs are supplementary. So that means their measures are going to add up to 180. So 3x plus 12 plus 8x plus 36 is equal to 180. So group the like terms and we get 11x plus 48 is 180. Subtract 48 from both sides. We get 11x is 132. Divide that by 11, and we get that x is 12. All right, last example for today. It says if ray AT bisects angle SAV. All right, so ray AT bisects angle SAV. That means that these two angles are congruent to each other. The measure of RAS from R to A to S, so this big angle over here is 4x plus 62. And the measure of TAV is 3x plus 14. They want us to find the value of x. My question first is, why aren't RAS and TAV a linear pair? Why are those not a linear pair? Yes. Oh, they do make a straight line right here. Pardon?
You said, why are they not a straight line?
No, I said, why aren't they a linear pair? To be a linear pair, there's two things. One is they have to make a line, and they do. What's the other part?
Oh, wait, really?
They have to be adjacent. They have to be right next to each other. You see how there's this gap in here? So those two angles aren't adjacent, but these two angles are congruent. So this angle is 3x plus 14. So what do all three of those angles add up to? 180. So my equation will be 4x plus 62 plus 3x plus 14 plus 3x plus 14 is equal to 180. Grouping the like terms, that's 10x. Let's see, 62 and 14 is 76, plus 14 is 80. Yeah, so 10x is going to be equal to 100, so x is 10. And I apologize, earlier I said that your homework is in the book. It's not. You have a worksheet for homework tonight.
Wait a minute.
Yes.
That is that supposed to be? I'm pretty sure it's supposed to be 90, not 80.
60 and 28. Oh, that should be 90. Thank you.
Because X.
Thank
is
you.
9, not 10.
Nice catch there.
So this is going to be 90. So this is 9. Thank you very much. There are some days when I can do calculus, but I can't add. It's a problem. I'm working on it. Yes, sir.
So that 10x, what do we add up to get the 10x? The 4x, 3x, and 3x. Okay, so we add up all the x to that.
Yeah. Okay.
Yeah, that's fine.
All right.